So the big picture for this lesson is modeling data using linear models. Here's a scatter plot, and what I'm going to do is I'm going to do a visual method for modeling data. You can either use visual, which is not really that accurate, or you can use technology, which is much more accurate. So where does it look like the middle of these points is? Maybe like that, maybe more like that. I don't know, something like that. I'm just going to use the first line because that's pretty close. So all you're doing really here is eyeballing it. So we're saying that this line is going to be used to model the data in general. And it doesn't go through every single point. It's just to make a model of the data. And it's not 100% accurate, but sometimes these are close enough. So now we need to figure out the equation for this line. And I'm looking for points where it looks like the line goes through grid lines. That's a point right there where it goes through the grid line. And let's see if there's another one. Well, this one's pretty close. So we're looking for points that go through the grid line to make it easier to find the slope of the line. Okay, so the rise is 1, 2, 3, 4, and the run is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the slope of the model is 4/9. So then what I can do is I can use the point slope formula to go ahead and write an equation for the model. Y minus y1 equals m times x minus x1. Remember, x1 and y1 are coordinates for a point that is on the line. I'm going to use this point here. The coordinates for that are 1, 2, 3, 4, 5, 6, 7 for x, 4 for y. So 7, 4 is the coordinate. So it's going to be y minus, and the y1 is 4, equals the slope m, 4/9, times x minus 7, which is the x-coordinate. So it's a perfectly valid linear model. Now if you wanted to, you could write it in y equals mx plus b form. You could distribute the 4/9 and then add 4 to both sides. That's going to involve fractions and common denominators, so I'm just going to leave it like this. So what can you do with this model? You can use it to make predictions. I mean, what if I want to know if x equals 15, y equals whatever? How do I find that out? One way would be to eyeball it from the graph. Another way would be to input 15 in here and see what you get. Well, let's try that. Y minus 4 equals 4/9 times 15 minus 7. So it's y minus 4 equals 4/9 times 8. So 4 times 8 is 32. That makes this side 32/9. So then it's y minus 4 equals 32/9. Add 4 to both sides. So y equals 32/9 plus 4. A common denominator in ninths is 36/9. That's the same thing as 4. So we're adding 32/9 and 36/9, which is 68/9. So the decimal form for 68/9 is about 7.6, so we're just going to use that. So y equals 7.6 when x equals 15. Right there, yeah, that does look like about 7.6 for y. So that's how you can use a linear model to make predictions. And this is just by hand, and this is all eyeballing and estimating. If you use a calculator, you can input all the values for the x and y, and then the calculator will calculate a more exact model, and it'll even tell you how precise it is with the correlation coefficient. And that's shown in detail later in the lesson. So that's the big picture for this lesson.